Welcome everyone to DRJ's webinar series. I'm Bob Arnold, President here at Disaster Recovery Journal. We thank you for attendance today and we hope you gather some great information from today's webinar. Everyone's phone has been muted and we ask you to utilize the question panel found on the right hand side of your screen. Our speaker today will attempt to answer as many of these as possible at the end of the webinar. Today's sponsor is Quorum. Today's topic is Cloud Manage and Recover with Hybrid Cloud, when minutes matter most. Our speaker today is Larry Lang. Larry Lang is Quorum's CEO, and he will focus this webinar on the importance of going beyond traditional backup methods to implement a disaster recovery and management plan that enables business continuity and prevents costly downtime. With no further introductions, I'd like to welcome and turn the mic over to Larry.
Very good. Well, thank you, Bob, and thanks to all the attendees for tuning in. I have, of course, some prepared remarks about what's going on in the industry, what we've seen with customers, and new developments in technology that allow disaster recovery to really improve that we want to share today. And we've also left a good time for questions and comments, and I'll look forward to hearing from you. So please give those some thoughts because we'll look forward to that part of the conversation as well. Some of you may not have heard of Quorum, so I thought I'd just start with a quick introduction. We're a relatively new company out of Silicon Valley here in California with a number of engineers working on this technology. Perhaps the most interesting thing to point out is the technology was originally developed in the defense industry where the disasters they need to recover from are, for example, incoming missiles aimed at ships and so forth. Hopefully none of you ever have to deal with disasters quite so dramatic as that, but you can see why that environment needed to have a more automated, rapid way of recovering. And our company is all about taking that technology and applying it to the commercial world. So that's what we'll be talking about today. As I'm sure you're all aware, after all you're motivated enough to join me today, the importance of protecting the digital assets and applications of companies are more important than ever. This has been something that's been really interesting to me as I get to meet customers and prospects as they travel around the country, which is that increasingly computers are on the very front lines of this. Just one story that illustrates this point. I was talking to a customer who is in the commercial refrigeration line of work, and he said, you know, years ago the only thing they used computers for was for printing bills, and as he jokingly said, if I have a computer crash and the bills are 2 days late, why the customers never call to complain their bill is late. Now, though, increasingly they use their computer just to monitor the warehouses of food and produce and so forth that they're refrigerating, and that's part of the service they provide. So his tolerance for downtime has decreased from days to minutes, and that's, of course, very similar to what you'd see at a law firm, accountancies. A lot of accountants, of course, the day before taxes are due, there's no way they can afford their computers to be out for a couple of days. So in just every sort of form of business, the need to make sure that the computers are always available after any sort of disaster is really key. So let's take a look at some of the kind of disasters that we see out there. The ones that, of course, grab the headlines tend to be natural disasters. One case study to share is from about this time last year when Hurricane Irene hit the East Coast and particularly hit the state of Vermont very hard. There's a lot of flooding of that area because of the heavy rain. I bring this one up because, to their credit, the CIO there, you can see his picture, published a great deal of information about how things went and what they learned and so forth, and it was great that they shared that. What happened in their particular case was the Winooski River overflowed and flowed into a basement data center in Waterbury, which is just upstream from Montpelier, the capital. And as he says in the comments from there, that the plans had never been tested, and that's a common theme we'll see. You can see how difficult this was for them. A lot of computers that no longer work, mud all over the patch panels and so forth, took weeks to restore normal operations. So that need to test the plan, in their case the plan was to move all the equipment to higher ground, didn't happen fast enough. The river rose too quickly. Another case study from a while back comes from New Orleans, and of course when we hear about New Orleans in the context of disasters, we tend to think about Katrina, But actually, this happened 5 years after Katrina. An interesting thing, because they managed to survive perhaps the worst hurricane in U.S. history, but one of the very worst, and yet it was a simple hard drive failure that got them in this case. What happened was the parish of Orleans, and in Louisiana, the counties are called parishes, if you're not familiar with that. Their civil district court maintains an index computer that explains where all the property transaction records are kept. It's across a couple floors of books of mortgage records. Unfortunately, this computer crashed, and they had not been testing it how to restore, and unbeknownst to them, they really didn't have recoverable data. In the end, the only way to remedy this situation was to re-enter by hand all the data from all those books. Close to 200,000 records had to be manually re-entered, which of course is quite the nightmare. And New Orleans and that area no one could buy or sell or refinance a house for about 3 months while they went through that process. The interesting sort of side about this is the ACLU has recently sued because one thing that people rely on property records for is as collateral with bail bondsmen. So some people couldn't be released from jail even because of this problem, to give you a sense of how widespread it was. Now, the CTO there, you can see her picture there on the bottom, had actually raised the need for money to allow testing and other improvements to be ready. Didn't get that money. Sadly, the people who turned her down, well, they're still employed, but sadly the CTO is not. Really a disappointing case where a few $100s or $1,000 could have saved what ended up being hundreds of thousands of dollars worth of damages just because of inadequate preparation and especially inadequate testing. Another example, and this is from among our customers, is a bank in the Midwest, and I'm sure for many of you who work with computers, this sort of problem will seem all too familiar. What happened in this case is that they upgraded, well, they changed, I don't know if it's an upgrade, they changed the firmware on their blade server, and it introduced a bug. And what the bug was that it misread the temperature sensors in the blade server and began to shut down some of the blades at seemingly random intervals. Of course, they didn't know this at the time. This became clear later. And fortunately, they had put in place a high availability recovery system, and so they were able to fail over to that system within an hour or so and keep running. But it gives you a sort of feel for the kind of things that those of us in technology deal with every day, namely this sort of, you know, not a hurricane, not a tornado, not a fire, just a bad firmware load that was misreading temperature gauges, mundane, and yet it had the possibility of bringing the bank down for several weeks. Fortunately, they had taken steps ahead of time to prepare for that kind of problem. So what are some of the lessons we can learn from all of this in terms of recovering from IT disasters in business? Well, I think the most important thing at the beginning here is that natural disasters tend to grab the headlines when there's hurricanes and tornadoes, of course, or out in California where we are, the earthquake worries. But one way or another, as scary as those things can be, they are not the most typical. Much more typical are your more mundane problems. So in those, I would include facilities, and by that I mean things that go wrong in the building. And you might think about fire, but actually we find that plumbing is much more common. You know, all it takes is the tenant upstairs to overflow a toilet, and you can find the lighting fixtures in your machine room have turned into shower heads, and that's not good. Or hardware failures. These are inevitable. Disks failing, boards burning out, power supplies failing. Those are quite common as well. Software problems. Updates that don't work out, as I described earlier, and of course the ever-present user error, as the pointy-haired boss goes and deletes all his email once again. How do you recover from that disaster? What I'd say is that what we discover is that there's a huge gap between ought to work and known to work. I'd say if there's one thing I'd ask you to take away from today's webinar, it's to make and keep a resolution to test your recovery systems on a regular basis. There is no bigger gap in technology than ought to work and known to work, and really the only way to bridge that gap is through frequent testing. So you have to assume that something that hasn't been tested recently probably won't work, and that's what we've seen in some of these cases. couple other points is that backups tend to be automated now. It's something that everybody knows they need to do. So whatever backup system you have in place, those are automated. And yet most recoveries are not. They're going to involve getting the computers and the tapes and so forth. And that's a shame because, of course, recovery tends to happen in the stressful time where having that automated so that you could have one click and be back in business would be really useful because of the stress and the excitement and so forth. And increasingly, it's not about backup, but how fast you are back up, which is what matters to people and what they're judging these systems around. Of course, all of these things take energy, they take time, they take money, and how do you think about that? Well, here's some interesting statistics to share. Start with a survey that the Aberdeen Group did, where they discovered the downtime costs of mid-sized companies. So we're not talking, something huge here. We're not talking about Boeing or Citibank. Just a typical mid-sized company can cost an average of $74,000 an hour. And that may seem like a lot, but I'd invite you to do some arithmetic, which is, there's typically about 200 business days in a year, and there's 8 hours in a day, typically a business day. So roughly speaking, that's about 1,600 hours of business a year. Divide that into the revenue or the budget or what have you of your company, you have sort of a feeling for the number of digits. Now, that assumes that it's all equally spaced. That's not necessarily true. If you're, for example, an accountant and it's April 14th, there's a lot more revenue flowing through at that time, at that peak time, than there would be if you just look at the average. But I think a lot of our customers, when they start out, don't really think about that number, and it turns out to be a key number to have some feel for, because it's that order of magnitude that tells you how much a day of outage is going to cost you. This, I think, leads to that second figure, which comes out of ESG's research, that most people feel that more than about an hour or so it's going to start having an impact on their revenue and other adversities. One adversity that is increasingly common among our customers that they cite is not just the obvious ones of revenues or whatnot, but the worry that if their computers were down, somebody would go on Yelp or some other social network and comment about that, and it would hurt their reputation for being a reliable supplier. So that's up the consideration as well. And then this last one, which is remarkable, but only about a quarter of businesses have actually tested their backup plan. And as I said earlier, if we've learned one lesson from all these experiences, is that any plan that isn't regularly tested isn't really reliable. So what can you do about this? Well, let's talk about the way people protect themselves. There's a couple of different ways there. One is people can use traditional backup systems. The most common thing that we would see is somebody running some sort of backup software to tape. Sort of surprising. That technology is decades old, but is familiar, and people do that. The challenge with that, of course, is that you end up with these tapes. It's difficult to verify whether anything actually ended up on those tapes, and the testing is somewhat inconvenient. And of course, you also have the worry about getting the media off-site. Perhaps you use a professional service, an Iron Mountain, or somebody comes by to pick up those tapes. I was recently talking to one person who says, "Well, I just try to remember to put them in the trunk of my car before I leave in the evening." And it's, better than nothing, I suppose, but still a bit worrisome. So as you think about rapid restore time, this is not going to cut it. It's going to take hours or days to get the tapes back and restore from them. What people would like to do if they were a large company would be to create a replicated data center. Certainly if you were running the NASDAQ stock exchange, what you'd do is build multiple data centers and hook them all together and so forth. The challenge with this for most people is that the requirement for uptime may have gotten tighter, but their budget sure didn't get any bigger. And the notion that they can simply buy at least 2 of everything plus all the technology needed to hook it together is not practical for your mid-sized businesses. On top of that, of course, it's complex to integrate these sorts of systems and build them. There's a manual, for example, from VMware that involves the products from 7 vendors, runs over 200 pages. It's a good manual. Certainly if you have the wherewithal to have people dedicated to this kind of project, it's not a bad idea. But this is not necessarily practical for a lot of people. A lot of discussion these days about cloud, backing up computers to the cloud. And certainly for personal use, we strongly recommend this sort of thing. This makes great sense. I use one of these services for my home computers. But there's a difference there, with two differences really. It's, a fair amount of data, but not that much. And more importantly is, for my home computers, I don't really care about downtime. What I'm mostly worried about in that case is, for example, protecting my family photographs. As long as I can get them back in a week or two, that's fine. I just don't want them to be lost forever. However, for most businesses, that's not the case. First of all, they have a lot more data. We find that our typical customer has something like 3 to 5 terabytes of data, or even more. And if you do the arithmetic about how long it would take to download that from the cloud over the internet connection, why that could take stretch into days or weeks. So practically speaking, that's not what people do. What they do is they call up their cloud storage company and say, send me a disk. And you're back on the loading dock, waiting for the truck from FedEx to arrive, thinking to yourself, I thought I got away from tapes to avoid this sort of problem. And once again, the testing's a problem. So what to do about this? Well, start with this sort of observation that a lot of the traditional backup techniques are increasingly obsolete. Why is that? Well, traditional disaster recovery assumed that if a physical computer was destroyed or broken or otherwise, that what you'd have to do is go to the computer store there and buy a new one. And it would take hours or days to purchase a computer or the parts you needed or whatnot and get that all installed and so forth. And therefore, using the tapes to be able to restore that, the fact that it might take you hours or days to get those tapes was not that big a deal. Also, it was expected that because it was such a bother, you couldn't test it that often. And in fact, if you tested once a quarter, that was a good idea. So that was sort of the assumption based on those times. But what's changing that? Well, really a couple things is changing that or making that approach obsolete. Now, one is cloud. And an important thing about cloud is it allows people to purchase computing and storage capacity as a service. So this is nice, for example, in terms of replicating an infrastructure, in that you can buy that as a service rather than having to buy that all yourself. So that's a good thing. And it does allow the incremental changes to be sent over the internet connection, which avoids having to do the daily pickup of tapes or putting them in the trunk or whatever that is that people do. But as I said, that's not enough, because if all you're doing is using storage in the cloud, you have a problem, because the bits are essentially trapped there and not doing anything useful until you can liberate them back into a new environment. What makes that more possible is another relatively new technology, virtualization. And this is key, because with a virtual machine now, you can have a new computer, in the sense of a virtual machine, in a matter of minutes, and allows you to have the rapid creation of replacement systems. Of course, these replacement systems are only useful if the restoration to them is automated so that that can happen quickly. It doesn't matter if you can have a virtual machine quickly if the restore from tape, for example, still takes you many hours or days. And so the task we set for ourselves at our company, at Quorum, was to try to figure out a way to bring these technologies together with some other key technologies to be able to create a system that would make this sort of recovery practical and achievable for mid-sized businesses with more constrained budgets and personnel. So how does the system work? Well, here's a pretty typical environment for the customers. Might not be standing up looking quite so cheerful, but aside from that, pretty typical. Might be a dozen servers or so. Our typical customers have perhaps half physical Windows servers, half virtual machines of one description or another, maybe VMware, maybe Hyper-V, running various applications. What we add to the system to be able to protect it is an on-site appliance and an off-site system that can either be another appliance for customers who prefer to purchase things all as a product, or a cloud service, which is increasingly popular, as I mentioned, for people who don't have a second location and want to be able to do things. If something should happen to one of the servers, you can see the SQL server there blinking red and the application blinking out because that thing is gone. Maybe it's just a power supply failed or whatever the problem was. In that case, rather than having to get a new machine and restore, a virtual clone is brought up of that, and right away people can be back up and running. That's, for example, what happened at that bank that I described, is that in that case it was that firmware that burned, that shut the machine down. They were able to come back up with replicas of those servers, and there you see the IT person smiling because in a matter of minutes he was back up and running before people could even come and complain. And there's his boss smiling, probably going to give him a promotion or at least a raise or something. So it's all good stuff. How does this actually work? Well, what's going on here is that on a regular basis, some people do it once a day, but of course you can do it more often, perhaps every 15 minutes. People are taking snapshots of the servers and sending them to the system where we create a repository. That much is very much like automated backup, but what's new is we're also doing the automated recovery all the time. The recovery is going on and creating these virtual clones of the servers, which we can then test regularly. So the notification that the customer gets is not just that that the backup happened, but in fact that the restoration has happened as well, and the server can boot up and is ready to go. That way, if something goes wrong, in this case the mail server turns red, go in, click on the screen, and a clone of that comes up of one, or it's also quite possible to run multiple replacements as well, either on-site or if the whole site has been compromised, and the off-site cloud side of that. Gives you sort of a feel for what the screens look like, standard sort of web-based control. But the reason I bring this up is to discuss testing. And as I said earlier, we think that testing is one of the most important parts of this. But one nice thing here is that every single one of the servers is booted up every time the snapshot is taken, and that way the administrator, the IT leader, knows that the server is ready to go because it booted up. So oftentimes people are going from, maybe not testing at all, or at best restoring from tape for a test once a quarter, to knowing every single day, perhaps multiple times a day, that the servers that they would use to recover booting up both on and off site. This also allows people to bring it up in a test mode, not just on the production network, but allows people to bring it up in a test mode that allows them to, for example, check on things. So for example, suppose you had an Oracle server and there's a new version that you'd like to test the upgrade on. Rather than risking your production environment, you can bring up the test clone version, apply the upgrade to that. If it works, great. You know that it's relatively low risk to apply it to your production environment. If something goes wrong, no harm. Just throw away that clone and figure out what went wrong and try again. And that way you're not just recovering from disasters, you're avoiding them in the first place, which is pretty crucial as well. So what we're combining here is that hybrid cloud service, the virtualization. There's a lot of other technology here too. Source deduplication is a key aspect of this to keep the redundancy down, and really the automation is key. As I mentioned earlier, it's great to automate backup. After all, you don't have to deal with that every day. But it's at least as important to automate the recovery. You don't want to have to be reading manuals in the moment of stress. And to be able, with all this technology, then you can recover in a couple minutes, restore to the original system in your convenience. Remember that bank story I told you? They could take a couple weeks to figure out what had gone wrong with their blade servers and then test to make sure that the fix was working. They didn't have to do it all in a panic. And you can be sure about that because you can test every day. A number of different customers here. This is not all the customers, but just a selection of the type of folks that we have. It gives you a feeling for all the different kinds of customers. Ranges from savings banks of various descriptions that you can see here to, well, one that I enjoy talking about is Weddell Swift there. They are actually in the UK. They're not a US customer. They're overseas, and they work on distributing sausages. And you can see why in warmer weather, you don't want trucks of meats and sausages sitting in the countryside with not knowing where they should go next. So that was what motivated their need for rapid recovery time. You can see a whole variety of different folks there, some quotes. One of the pleasures of this business is that when we look out for somebody and help them recover from a problem, they tend to be pretty pleased with how that worked out. And we get some great quotes from them talking about how well things have helped them out there. So let me just sort of summarize here, and then we'll throw it open to questions. I think the most important thing, and presumably you think so too, that's why you joined us today, which is that IT systems are more important to business than ever. I think one of the key skills for IT professionals now is being able to articulate for the company and keeping track for the company, at least an order of magnitude number of why it's so important in terms of dollars and cents to keep these systems running and to make sure that there's recovery systems in place. Also, I think it's important to remind those who are making budget decisions that it's easy to think in terms of just earthquakes or tornadoes, and while those are scary, frankly, it's easy for people to think, well, maybe I'll spend on that next week. But as I said, most of the problems are actually much more mundane than that. Their power supply is failing, their disks crashing, stuff like that. And being able to recover from that is equally important. As the New Orleans case showed, that was just some bad setup, some old equipment, could have been solved for a few $100s, and instead they ended up being out of service for months and costing hundreds of thousands or perhaps even millions of dollars. The good news is that there's new technology available to make one-click recovery possible, that there's no reason to settle for backups that would take days to restore, because now, thanks to the combination of cloud and virtualization and particularly automation, along with source deduplication and these other technologies, all of this kind of makes it possible to have one-click recovery. That means that tests can run every single day, even for firms that only have a couple IT people, no problem, because the tests run themselves and they only have to check if something goes wrong. And it also means that if anything does go wrong, they can reactivate this with, even we've had customers come in via their mobile device and turn on the recovery system, say that they're a kid's soccer game or whatever, no problem, turn on the recovery system, make their way back to the office and sort out what happened later. You can see this makes recovery possible in a couple minutes. Also means that the full restoration can happen when it's convenient for you and for the business, and that this daily automated testing is now state-of-the-art, that anything less than testing your recovery system every single day is, in a sense, leaving yourself at risk that you just don't need to take. And the good news is this new technology makes that possible. So I'll close my remarks by just saying, if you're interested in seeing a demonstration of this, we actually do webinars where we crash servers and show the recovery happening. I'll confess that we don't actually set fire to the servers. We do that to be a little dramatic in the slide. It get expensive, and probably the fire marshal will have some questions. But we do actually crash the servers and show people how the exchange or the databases or whatnot come right back up. And we'd, of course, be delighted to schedule some time with you to do those kind of demonstrations, because a lot of times getting a real feel for how it works is best done by seeing that demonstration. In any case, at this point, I'll once again thank you for joining us and see if there's any questions or comments or clarifications I can offer in the remainder of our time together.
All right, thanks a bunch, Larry. And as Larry mentioned, we do have plenty of time here for question and answers. If anyone does have a question, you can utilize the question panel found on the right-hand side of your screen. We've got a couple here already for you. Can you provide some detail on bare metal restore? With a big server, how long would the users be out of service?
Right, that's a good question, and in fact the question sort of shows how things have changed. So bare metal restore takes about as much time as it would with backup. After all, there's sort of physics involved, and if you have a couple terabytes that you need to put back on a server, why that's just going to take some time. The big difference, though, is that the user is not out of service for that time, because even while the bare metal restore is going on, our system can continue functioning with that clone. Of course, as that happens, new data is being added. So there does come a time where there's typically about 5 or 10 minutes where you want to sort of stop people from accessing the system and do that last incremental restore to the server. And there'll be a bit of out-of-service time for that. But you can choose when that is. You do that in off hours, let people know in plenty of time, and so forth. So while the restore to the initial server is going to take a while, the nice thing is the users aren't out of service. That's also nice because that way you can make sure the restore is working properly. Think about that Blade server case that I gave you earlier, right? If they'd been rushing, like here's a patch from the manufacturer that they say fixes this. Well, if your user's out of service, you're going to rush that patch in. You're going to have to trust that it works. Maybe it does, maybe it doesn't, but you're going to be rushing to get the bits back on that server and running again. In this case, because they had the recovery system running, what they could do was apply the patched firmware, then run it, just nothing on it, just run the computer to make sure that whatever heat problems were coming up before were in fact cleared by the new firmware, then fail one of the services back, make sure that that worked, and do it incrementally. So a lot of times what happens with disasters is because the users are out of service, it forces the IT professional into high-pressure decisions, adding to the risk, sometimes actually making things worse. The nice thing about this arrangement is that because the users aren't out of service, they're still able to keep running. They can make more measured decisions and sort of take their time with each step of the way. In fact, what we see is sometimes people use the system to migrate. We had a customer, for example, who wanted to upgrade their existing server. What they did was fail over to our system, let the customers run on that while they installed the new system, and then they were back up and running. So the bare metal restore, in terms of that part of the function, takes about the same amount of time. That'll be hours or perhaps longer if it's a very large server. But the good news is that the users are only going to be out of service for a couple of minutes.
All right. How do you handle the examiner regulatory concern regarding data security?
Right. Well, so that's going to vary on the various regulations. It comes up all the time, as you can imagine. And there's different arrangements depending on what it is. So, for example, HIPAA has very strict requirements about encryption, and we have a number of healthcare customers who we've set it up so that they can do encryption at rest and encryption, of course, between the units as well. So depends whether you're a bank or a healthcare or what have you, but there's different ways of setting that up. And of course, we also are in 10 different countries now, and different countries have different regulations as well. So usually part of the process is spending time with the customer, understanding, given their business, what regulations apply, how do we set things up properly to do that. But, you can imagine that there'd be no way we could do this if we weren't set up to provide those sort of encryption sorts of things. One other thing I'll mention about this is that in addition to providing the sort of real-time protection, we also do archiving, and we can archive data back for years, in fact. And there, it becomes a little bit different. There, what's very important, of course, is not just data security, but good logging and tracking, so that if any sort of legal or tax audit sort of thing comes up, you can show exactly what went on and make sure that things don't expire. So we've set that up for a number of folks. For example, the accountancies typically are looking for at least 7 years of archiving to keep their customers' data around for that long because of IRS regulations. So we also are able to handle those situations.
All right. Can you use the appliance to have a private cloud on it?
Absolutely. That's comfortable for people. What we do have some customers do who have essentially built a private cloud for themselves where they use this and set it up privately. Or sometimes what they'll do is work with a reseller or partner to do that. We have a very good partner in the East Coast who has another actually in the Midwest, several who have sort of used the system to create a private cloud dedicated to one customer, and they're comfortable with it that way. Each customer is going to have sort of a different balance of what they want to do for themselves and what they want to have as a service, and so the technology is pretty flexible in terms of is it all privately owned, private cloud. It's never really a public cloud because even when it's a cloud service, we certainly wouldn't be bringing up our clients' servers naked on the internet. We actually put it behind 2 firewalls, and all the access is done through VPNs. So that's still private in that sense. But the notion of having a cloud setup that's dedicated to one customer, private cloud in that sense, is actually quite common in our setups.
Here's a question. How do you actually virtualize the servers? VMware, Hyper-V, other? Right.
So I divide this into 2 parts. One is what sort of virtualization we support in terms of the infrastructure, and then what ingredient we use. So it turns out that within our appliance and within our cloud, we're using the Xen hypervisor. But it turns out that we support all of the common hypervisors out there. So we have customers who, certainly physical servers, that's obvious, going back to Windows 2003. But also we have customers who are using ESX, various setups of VMware, Hyper-V, some who are using Xen, although Xen's more commonly used in infrastructure like we use it. That's what most of the major cloud providers use. So I'd say in terms of our customer environments, what would most common would be a combination of physical servers and VMware servers, and we certainly support that. So I'd say that in each of those cases, what we've done is written software, and this is a crucial part of the technology we've created, that in real time is essentially doing an ongoing either P2V or V2V process so that the clone is ready to run in our environment. But that's independent of the hypervisor technology that the customers use. In fact, on the previous slide where there was a a list of customers. One of those is Coal Services, as one example. They happen to be in Australia. One of the reasons they went with our system was because they had a mixture of not just physical, but they actually had a mixture of hypervisors. I think they'd grown through acquisition. And what they found was that some products out there, only worked with one kind of hypervisor. And one of the things that prompted them to go with our system was that we didn't care that they had a mixed environment. We could back that up and create one-click recovery systems for that, whatever they started with.
All right, if a vServe host fails, can I start up all the VMs on the device?
Yes, we can certainly do that. Obviously, the rules of physics still apply, so an important aspect of this is to dimension the system appropriately in terms of the memory and the CPU and everything else involved. Sometimes what happens is we've had customers who dimension the on-site system just to be able to recover a few machines on the theory that the kind of failures that you're likely to have there might be like a power supply or other thing like that. But clearly, if you had something like a blade server or a number of virtual machines running that could fail all at once, you'd want to dimension it to be able to recover all of that. Then for the off-site portion of things, people definitely want to dimension that, and we work with them to dimension that so that we could run the entire enterprise on that system if it were to come to that, and that's quite possible and part of what we routinely test.
All right. Is there any integration with public clouds?
We've looked at that, but to date there is not. We'll continue to look at that, but we were a little bit uncomfortable about some of the security and performance issues. We need to be able to guarantee our customers the security and the performance that they expect out of this. And so this has been built as a private cloud that we do for ourselves. I suppose it would be possible to protect nodes that people had running on a public cloud, although we haven't had anybody make that request. It certainly would be technically possible, but we haven't done that to date.
All right, and we only have one final question here. It's basically a more housekeeping tip. It's asking if we are recording this, and we are recording this, and it'll be available for a year. We'll be sending that link directly out to you. So any parting words here, Larry?
Well, first of all, again, thank you, everyone, for joining. I know you all are busy, and that's a compliment to you that you take your responsibilities in protecting your infrastructure seriously, that you're investing the time to learn about the new things that are possible with the new technology. So thank you for investing that time with us today. Then again, if you'd like to see this in action, we find that a lot of times, since it is a new way of doing things, seeing a demonstration is the best way to get more intuition about, for example, how the testing works and so forth. Would invite you to drop us an email if you're interested. We'd be delighted to do that, of course. And lastly, I would just say that whatever you decide to do with us, I would urge you to go and make plans to test your system. I feel kind of like the dental hygienist who reminds you to brush and floss regularly. The testing is crucial, and if you take nothing else out from today, whatever system you have in place, make a point the next week or so to run it through its paces, because I think that kind of testing is crucial to make sure you're in a safe place. So with that, I'll wish you good luck and good recovery. Hope you don't need it, but best of luck getting things set up properly. And again, thank you for spending the time with us today.
All right. Thanks again, Larry, for a great presentation. Thanks again, everyone, also for their attendance here today. We hope you gained some great information from today's webinar. We'd like to thank Larry for his time here, as well as Quorum for sponsoring today's webinar. Again, we'll be emailing everyone a link to the recording of the webinar. You may view it as frequently as you wish or share it with your peers. If you have any additional questions, please contact Disaster Recovery Journal. Thank you again, and this now ends today's webinar.